Brings several solutions. Well, there was a very recent study, February 2023, by the Chalmers University on the challenges related to digital transformation of the maritime logistics and especially focus on liner shipping. And what was interesting to see there is from all interviews coming from the shippers, the main challenges were practically technological, operational, strategy dependent, and also challenges related to governance and organization structure. So what this study identified, and that's very interesting to see, is that technology is out there, yeah, but people are not skilled to use it. Also, there is a resistance to get prepared. There is a lack of access to budget the right transformation. Also on strategy levels, there are gaps in understanding which technologies to implement, where. Is there any vision on strategy and culture level for digital transformation? And of course, though in the maritime industry is a very customer-centric industry, again, digital transformation should also build around that. And in the case of the currently fast-evolving digital transformations in the logistics industry, there is an issue. There are no standards that could help to unify and have the same common language between the different stakeholders to operate in an efficient and smooth way. So there are different levels of challenges and, of course, security-related challenges around cybersecurity, around security of finance and data flows. So to conclude, the mistakes that have been done in other industries, in either in oil and gas or logistics or finance, could be, or the best practices that happen in these industries could be good paradigms for the shipping industry to evolve towards the digital transformation.
Thank you, Mrs. Georgopoulou. I would like also one comment from Dr. Kokarakis about the digitalization and how this will change the shipping industry, apart from the AI.
Digitalization actually is very important because decarbonization goes hand in hand with digital transformation. It is related to artificial intelligence discussed before because it is based on data collection. As we say, data are going to be the commodity of the future, a valuable commodity. But, of course, like in the artificial intelligence, the data must be accurate. So we must have in place a filter that will eliminate what appears to be a bad measurement with a proper filtering. It is going to enable remote working, monitoring and control. We are going to monitor and take data from equipment, which will facilitate their well-being. We are going to be able to predict when to change them and take care of it. It is not bad to have a failure of an equipment, but we must be ready to replace it. It is going to help face the cyber attacks that we see happening a lot these days, information sharing because of the power of data. And another example is that with digitalization we can solve very complex problems, like, for example, the response of a vessel in waves, which is better handled by relying on actual monitoring and measurements. And in general, I believe that digitalization is a sine qua non to achieve the targets of decarbonization.
Thank you, John. In this point, our chairman, Mr. Tsavliris, wants to have a comment.
One minor point, if I may say, without wanting to sound controversial, We've spent a lot of time, even in the earlier session, on artificial intelligence. I'm not trying to bring romanticism to the picture, or being imaginative, but I must say that with creativity, which required our industry, we cannot disregard emotional intelligence. Emotional intelligence, in my view, on many phases, has been misunderstood. Some of the most prominent ship owners we have in Greece, one who is very close to Captain Panelists, I think effectively you want to summarize what he's been doing in his career. I think his triggering mechanism was emotional intelligence rather than artificial intelligence. So I'd like to just place the point that obviously we have artificial intelligence is a very important factor in our way forward, but we shouldn't disregard the very predominant and very strong elements, especially with us Greeks, because we've literally never really done anything by the book. We're perceptive, we go by our gut feeling, and that's what has allowed us to progress and do what we've done over so many years. In fact, established, you always mentioned earlier, even on the regulation systems we hear, you have 100 points which you have to listed what you have to do, which if 90 of them are irrelevant. So let's not disregard the fact that creativity and being progressive is also very dependent on emotional intelligence. Thank you.
Thank you. It was a very nice comment. Now we start the second part of the session.
Can I say something before you close that? In response to Mr. Tsavlidis' comment, which was very valid. That's why there is concerns among those who understand artificial intelligence better that it might take over. It might take over human intelligence. And to give an overall view of what artificial intelligence is, because we're talking about the application on ships, but what is it? It's machines learning by themselves, and the way they can do that is by having many calculations per second, doing it and getting all the available information. Now, big companies like IBM, Google, and others are working on what they call, you might have heard it, quantum computers. Quantum computers. Now, a normal computer right now uses the dyadic system, which is 0 or 1. It's like having a switch. It's either on or off, an electric switch. And therefore they can do thousands of calculations per second, a supercomputer. When you go to the quantum computers, they use qubits. The qubits, they don't use the 0 or 1. What they can do is they can do the 0 and 1 at the same time. It's like having an electric switch that's closed and open at the same time. Therefore, you put two qubits together, you can do 4 calculations at the same time. You put 8, you can do 16 calculations at the same time. Okay, no open and close anymore. So we're talking billions of calculations per second. The problem is they need a lot of cooling, but they have the prototypes. So as soon as we have working quantum computers, artificial intelligence will take off. And then the concern is, if you have something that's 1,000 times smarter than you, can you control it? Because it knows that it needs electricity, and it knows you are the one who might pull the plug. So this is in the big scheme of things about what artificial intelligence is, and we have to be careful. Even Elon Musk and Stephen Hawking said that we have to have controls, United Nations controls on artificial intelligence. You cannot have every researcher and every research lab just do whatever they like, the same way we had controls for nuclear power when it first came up. And it was under United Nations overview. So that's just my overall comment, yeah.
Thanks for your input. Also, Dr. Kokarakis wants to make a comment.
Thank you. As my friend Stavros Hadjigrigoris would say, artificial intelligence has no soft skills, only hard skills. But I advise to Google the word technological singularity, Google technological singularity to see the future creation of the so-called superintelligence machine that will be much more intelligent than every human being combined. So have a look on the emotional implications of this creation.
I would like just to say that artificial intelligence can cause unintentional harm sometimes. No matter all the good intentions that we have, it can cause unintentional harm. So this is why it has to be regulated, it has to be structured. I agree in principle that, okay, of course, a machine is much, much smarter than us sometimes, it can be. But at the end of the day, the result is not always positive, okay? Only in this context.
Fully agree and depends on what how you define the smart. Thanks, Maria. Now, actually, the first question for the second part goes for you. How can digitalization and the transition to clean energy be combined?
Actually, digitalization and decarbonization go, as Mr. Kokarakis said, go hand in hand. In net zero emission world, digital technologies and solutions will be the backbone for the energy transition. So we need digitalization in order to optimize the efficiency, to enhance the transparency, to make, predict any possible problems, and also to test any virtual solutions. It is, we see regulations that are already coming to force for CII. They are requiring, charters will require, they are already requiring a CII which is based on the data that they are verified. The verification of the data, it's not only the statement that the classification society are giving, but it is also what their own digital tool is producing. Okay, so it starts from this. We cannot have a zero emission in 2015 without being digital.
Thank you. Now, one very important question for Mr. Zachariadis. Panos, is there any realistic hope for shipping decarbonization by 2050?
Realistic. Yeah. Well, on paper, we can achieve anything. And so they can achieve it on paper for sure. But in reality, the way with the current technology, including all the green fuels that we're talking about and all that, the answer is no. So we need new technology. Nuclear is one possibility, the fourth generation nuclear, not the nuclear we know. A big breakthrough in batteries is another possibility. But let me explain a little bit why the answer is no with the green fuels. Because the green fuel shipping will need, green fuels, first of all, is all of them, most of them are made from hydrogen, okay? And the reason we're talking about ammonia is because it's a hydrogen carrier, is an easier fuel to handle than hydrogen, which is a nasty fuel, and we'll talk about ammonia perhaps later. And then you have methanol that also is made from hydrogen, from green hydrogen. So you have green hydrogen, you have those green fuels. To make this green hydrogen, you need to make it from electrolysis of the water, not from natural gas that's made most of the time. And the electricity that you give to make that electrolysis has to be from renewable power. So to make the amount of green fuels shipping needs, you need more than 50% of the current global amount of renewable electricity that we have, all the wind turbines and the solar panels and all that. You need more than 50% of what we have now to make those green fuels. Let's say, which is not foreseeable, but let's say you are going to have that by 2030. There's no way you're going to have it, but let's make an assumption. Then you have the following problem. And let's say you have all this green fuel, either green ammonia, green methanol, whatever. If instead of using that green fuel to ships, you use it at shore for electricity productions to transport all that, then the amount of CO2 you are going to reduce the emissions to the atmosphere will be 8 times more than if you use it as ships. So the question is, let's say we have all this green fuel we have. If we apply it to factories instead of ships, we can save 8 times more CO2 reduction than ships. Would there be anything left for ships anyways? I don't think so. So we have a huge mountain to climb without new technology.
Thank you, Manos. Now for Dr. Kokarakis, the $1 million question. What fuel will ships be powered by in the future?
Give me the 1 million and we'll reply. This is indeed it's a $1 trillion question, actually, a few trillions. First of all, I would like to say to my friend Panos that yes, we need electricity to create hydrogen, but the best way to get electricity is nuclear. So we are going to have nuclear energy to electrolyze hydrogen, and we solve the problem of electricity. For the ships, it can wait until we are absolutely certain that it is safe. This is what he said. Yeah, but electricity can be created with nuclear energy. It is the so-called pink hydrogen, and in that case, we do not really. We have an easy way out, because
John,
if we.
Sorry to interrupt. The question was until 2050. Until 2050, no matter what, you need to have all these green fuels right after 2030. You're not going to have them, whether you use nuclear or not.
Hydrogen is, and this is actually in reply to my question. Hydrogen, I like to call it the mother of all fuels. So we're going to use hydrogen not as a means of propulsion, but as a feedstock for electric fuels, as a component of synthetic fuels. So we take hydrogen from electrolysis, and it is not only the electricity that is needed, we also need water. We need the Loch Ness to create hydrogen. So we need water. It cannot be produced at the Arabic countries, for example. And also we need electrolyzers. It's not only electricity. So getting also carbon by capturing, this is another issue, not necessarily on the vessels, from the air, on shore, we make synthetic fuels. We can make ammonia, we can make methane, methanol, and what is the beauty of the synthetic fuels, which I see are going to be they're going to have a large share in 2050. We're not going to see elimination of the fossil fuels, but the synthetic, the electrical fuels will be, in my opinion, they will be dominant for one simple reason. For example, biogas and electric methane, e-methane, can be used with existing infrastructure, and also there is no need to make changes in what is today LNG-driven vessels. And we see that by the record number of orders of dual-fuel ships, and one of the fuels is LNG. To avoid having stranded assets, it is advisable to be able to burn more than one fuel in a vessel. So in case something happens, for example, ammonia is promulgated as the fuel of the future because it has no carbon, it has other problems, but we can really future-proof our vessel by having the flexibility to change the fuel if possible. Thank you.
So, Mr. Chairman wants to add something.
If I may, I know Panos Zachariadis' views on ammonia, you've made it more than clear over the last few sessions, and it's very informative. What I want to ask is this. I'd like to ask both you and Yanni. is that I gather that a company called Maersk, you all know, heard of Maersk. Maersk is a massive company. Now, they've placed an order for a series of, I don't know, 10, 15 ships, which are deliverable in 2 or 3 years' time, and they chose as a second dual fuel as green methanol. Now, the question is how long is a piece of string? You've got a company of Maersk's massive, you know, they're a massive company, God knows how many ships they have, and they're committing themselves to a secondary or a second fuel, like a backup fuel, alternative fuel, in 2 or 3 years' time, which in all fairness, from what we heard this morning, what we're hearing now, this ship may be obsolete in 2 or 3 years' time. You know, you may have chosen to put ammonia or something else. So how does a company these days who's new building minded, who's thinking about the future, very correctly so, especially the public companies, because don't forget, ladies and gentlemen, public companies have to be seen to be correct, so they have to place orders to replace ships because they don't want to keep ships in overall terms more than 10 years old. So isn't this a billion-dollar question? I mean, we're talking about short-term solutions which are not actually resolving long-term problems. And that's what I think is very worrying, because the same as Maersk chose to have green methanol, if I gather, for their new buildings, somebody else may choose somebody else. You know, it's like playing a roulette. It's like going to the casino. No? Thank you.
Okay, the answer is Maersk is not stupid. And eventually they will burn green methanol. But until that time, they can burn partially gray methanol, which is only 10% better than fuel, and whatever green methanol is available, they can add it. So they can claim, okay, my ship is 30% reduced emissions. So they can claim that. So it's a solution that's available now, immediately, and it has the potential, when the green methanol is available, to have only 5% emissions. So it's available now. All the other things, ammonia is not available, an engine is not available, and I don't want to go into all the other problems, but maybe I should. I want to ask the audience, because Mr. Hadjigrigoriou mentioned before, we don't like the smell of ammonia. How many of you, raise your hand, have smelled ammonia? How many? I see a lot of people in the room, and I can answer that what you smelled is not ammonia, because if you smelled ammonia, you wouldn't be here to raise your hand. Okay? What you smelled is what they sell at the pharmacy, which is 5% ammonia and 95% water. Okay? If you 0.5% content of ammonia in the air, you take one breath, 0.5%, you're dead. Okay? So that's, I could say lots of other things about the ships, but that's something that scares me.
I am not a supporter of ammonia, but I'd like to say that the limit to smell ammonia, and it is absolutely harmless in that concentration, it's 5 ppm. In 5 ppm, which is much below the limit, so I believe that the guys that are here and lifted their hands had no risk. It is more than 5 ppm, actually more than 50, and it is also the exposure time that makes the difference. So ammonia is, in my opinion, is not a good fuel. Yeah, I do agree, but it is not so so dangerous. It's not so dangerous. We keep it where it belongs, in the tanks and the pipes. We can analyze where it's going to go in case of leakage, define the safe zones. This is.
Let me give you some information. The Japanese are making a ship ammonia, dual fuel. They made a submission to IMO on how they're going to keep it safe. And the way they're going to keep the crew safe, the engine room crew, is by using PPE. That's what they say in the submission. PPE is personal protective equipment. In other words, the engine crew will have to wear all the time something like, if we want our crew to be like astronauts, then maybe it's safe. But that's exactly what they say.
But the fact that at 5 ppm we have the odor to warn us of the presence of ammonia, I believe it is an advantage and disadvantage, of course, because it's not nice, but it is also an advantage because it gives us...
Because you can smell it and
yes.
And run away. And run away where? If there is a leak, you are in trouble.
Now the question was the question was on methanol. Yeah. So going back, last week, the corresponding group on life cycle assessment of fuels released their preliminary guideline, which is going to be discussed at the MEPC 80 in July, and in there you can see what is the grey methanol emissions of carbon dioxide. So in my opinion, it will not help the carbon dioxide footprint. We need a lot of unless we have green methanol. Green methanol is available to the giants, MSC, Maersk, and CMA SSM, but I'm not sure about the smaller operators.
Okay, this is very interesting debate, but we have to move on. One comment from my side about ammonia is that as per SOLAS is not allowed because it is toxic. And for this reason, the IGC code, it is something that at the moment cannot apply on board. We move to Mr. Rizos Krikkis with two questions. What green technologies look attractive for marine application, and what are the main concerns for their sustainability? Mr. Krikkis.
Hello, everybody. Thank you very much, Mr. Migadis, for your kind invitation. Please allow me to say only a few words about Oceanking, which has for more than 30 years continuously support training and simulations for the maritime academies, and recently has established Oceanking Engineering, which is a dedicated engineering company fully committed to a technical support mindset consisting both after sales and training. So within the Oceanking group, we are dealing with two vectors for green technologies. One vector is the energy storage systems, also known as batteries, and the other vector is the carbon capture technologies. Following the trends to adopt a more environmentally friendly technology, the introduction of energy storage systems has certainly gained momentum, mostly for short seas voyages. However, there are prospects for its application to commercial vessels as well. That is the typical bulk carrier and the tanker. To be more precise, a battery pack may be used for reducing the load in a diesel generator, especially during port staying. That is the zero port emission concept. Or it can be used as a propulsion system, an independent propulsion system for short sea voyages application. Although it appears attractive and simple and straightforward, this project is very demanding because the sheer mass of the battery pack on one hand and its connection to the ship existing AC bus on the other hand is a major concern. Batteries should be understood not as an isolated energy source, but integrated through advanced automation and alarm modules into the existing ship electrical systems. Therefore, integration plays a key role in the introduction of the battery into the existing fleet. In other words, the vessel's electrician is confronted to operate a main switchboard that will be far more complicated than the original one, because now he will have to deal with an electrochemical source which is DC, and it has to be connected to an AC bus. Consequently, you cannot do without proper and in-depth training of the existing crew to manage all these green technologies that we are planning to introduce. On the other hand, carbon capture is certainly another promising technology that allows us to reduce carbon emission through a cascade thermochemical treatment of the exhaust gases. Again, the project is demanding, since consecutive cooling, capturing, cleaning, regenerating, and separation processes are required. And of course, you need a tight and accurate, a very accurate control, to be precise, at each stage. Furthermore, smooth integration with the existing power plant is essential. From the practical point of view, the chief engineer has to master a complicated chemical process, how to extract carbon from a flowing exhaust gas. Again, we have to give to these guys in-depth training, and a serious one, because fortunately or unfortunately, chemical processes are not in the main educational knowledge of the typical chief engineer. Concerning the role of the concerns for their sustainability, we have to say that adaptation of green technology in most of the cases comes at the expense of simplicity. Therefore, the new systems will be more difficult, will be expensive, and will be more complicated. So there should be a serious investment in the training, both of the operators and not only the crew, but also on the side of the office, because each vessel has a number of superintendents that follow up. Thank you.
Thank you, Mr. Krikkis. So, Captain Bajaj, what changes are expected in the training of on board the vessels and in key personnel ashore? And also tell us about marine simulators, which are changing the technologies in the artificial intelligence, the machine learning, Internet of Things, augmented reality, virtual reality, etc.
Thank you. A topic very interesting, close to my heart, and disputed and touchy as well. Now, let's go to the first part. Two questions are joint in one. I will just go to how...
But please be short.
Sure. I know. Just to add to the first part, which relates to how. The how and the why part of it. So why we already know. We have artificial intelligence, machine learning, a lot of new things happening around the world. And equipments are changing continuously. So trainings have to be developed for that. New job profiles are being created. So for that matter, I would request Mr. Dimitri, in the first session, he talked about a couple of STCW recommendations that he's making. So one of the recommendations I would say, performance monitoring systems is something which probably everyone is using now, most of the companies at least. Now these performance monitoring systems require sensors. Sensors to be put on board, sensors, and these sensors should relay accurate information. So any faulty sensor not giving something, the whole purpose gets defeated. So the whole idea is greener shipping through the use of sensor, artificial intelligence, machine learning, and give a required output. But as such, who knows? I mean, I'm sure manufacturers are training shipboard personnel on use of these sensors, how to maintain, how to replace. But I guess this is something which is very common across the industry, should be coming under compulsory regulations as well. The performance, how to maintain performance monitoring systems. So this is one classic case study, I would say, that this can come because it is already implemented. For us, being training, whether simulator manufacturers or you call us as training solutions, what happens is in the industry, first of all, the things get implemented and then we get this much time to put it across. So, and there are various manufacturers with different softwares. So we have to cater to create a generic version of it unless you want, again, you want to get trained in all type specific 4 trainings together. So that is also one big pain, which we discussed in the first session as well. So the whole idea is the regulations for what needs to be there, the functionalities needs to be defined, properly defined. So that proper training solutions, generic ones can be created and they are compulsorily used. As I say, new job profiles, possibly maintenance engineers could come in a STCW as well. So there could be some electronic maintenance engineers with so much technology coming in with little coding experience as well. So that is one part that will be there. The second part that will change is a lot of these new prediction tools are coming in all the equipments. The equipments are analyzing, machine learning, giving you the best output. But the whole idea is get trained on how to use these predictive technologies. Ashore as well. Ashore, I would say a classic example is a VTS. So you're getting predictive technologies for the ships arriving ports. Or for that matter, on vessels, you are getting predictive technologies on EGDIS systems as well. So we have to again cater for that in our simulators as well as the training solutions that we develop. So whole prediction, whether that prediction is right, okay, machine has given. But after all, end of the day, a human is responsible if some incident happens, not the machine. Machine is a recommendation. So what we have to do is to understand, I'm sure the machines will grow and mature enough. Maybe another 10 years when we are discussing here, probably we will not be questioning what machines are doing. Probably they are doing the right thing with zero emotions and full performance. So, but the whole idea is the data is limited as of now. In shipping, there are no coordination between the shipping companies as to collection of data and putting in a common place so that all AI models can be created. It's all individual companies. Everyone is making their own model, claiming mine is the best. There is no joint effort between the companies to do it. So again, same thing, if the models can be created for training and simulations, so that will also add on to the excellent performance and the quality of trainings as well. So coming on to how, what we discussed in the first question. So the introduction of cloud technologies, high-speed computing, edge computing, has brought shore and ship staff together. So real-time decisions can be made. Participation can be through and through. So let's not keep the shipboard people aside and the shore side aside and they are doing individual things. It's all joint effort. It's all towards safety. It is all towards greener shipping. It's all towards better performance. So I would say these technologies are assisting joint operations. It's a continuous learning process, like we said, reskill and upskill. So reskill, upskill will apply to both ship and shore, whether it's for training or whether it's for the other operations as well. Coming on to the simulators, so a lot of emphasis will be given to the emotional quotient. So initially, these machines, the simulators were used for training of failures. Now we are reducing the failures by using artificial intelligence, using these tools. But the emotional quotient, so there will be technologies which will capture your audio, your video. There will be certain other sensors as well, human-machine interface sensors. There are a lot of different sensors that will come in play, and it will give you a full overview of where you should improve. So that recommendation from improvement will also come from the AI tool as well. So it will help in getting a better performance out of a person. So if the robots are working, say, 120%, the humans will also initiate, okay, instead of 70, let me give 90. Let me try to compete with the robots and give a better performance by better decision making, because now all the information is available right on his fingertips. Then we can also talk about augmented reality solutions are already in the market in many of the ships. So trainings for those are already coming up. So this is the next thing that will come in. Virtual reality. So virtual reality also gives a very real feel, especially useful to the cadets, I would say, who have never gone on board a vessel. I'll tell you, whenever I'm going on an exhibitions, the biggest attraction is students, cadets, because they want to see what a ship feels like, what it looks like. Okay, I have heard ship construction, I have heard this parts, this is a tank. What happens in a tank? Put him there. Use these technologies in universities at a basic level. Advanced level, you can have emergencies associated with virtual reality solutions. But for walkthroughs, for how things look like, the whole touch and feel, we are also going towards better controllers, even for VR. Probably in few years, we'll have bodysuits. The bodysuits will give actual feedback. You can probably lie down and do a underpipe maintenance just by wearing that suit. So it will come, for sure. Gloves are coming in, you already know it. There have been gloves coming in the market which are giving you actual feedback as to what you are doing. So the technology is growing faster, it is, and we have to live with it. The adaptability is has to be faster, again, same thing, you have to upskill a little faster. Training solutions also have to be developed, simulators for these new AR, VR, augmented reality, machine learning, everything has to come in. So whatever you are doing on board cannot be disconnected what trainings you are doing on the colleges or on the simulators. It cannot. Yes, you can have a hybrid mode of operations, like we discussed. You should have both online and offline. In the last session, we discussed that. It will be there. So use the power of online simulation to train from anywhere. I mean, the shipboard people can train whenever they're on board. Give them real scenarios for better decision support systems. So like I told you, automatic scenario-based assessments. So let the scenario be a real scenario. Take all the sensor data from the vessels, put it on a simulator, put him there. It's as good as he's a captain on board or he's a captain on a training institute or the same situation. Let him handle it. So instead of analyzing the incidents, we should at least make an effort so that incidents are not happen at all. So that's how you can integrate all these hybrid solutions. So that's why we talk about hybrid solutions. We don't talk about purely online, we don't talk about purely offline, we are talking about hybrid solutions. And the last part of it is, okay, recent years we are talking about autonomous ships. I really don't know when it is going to, there have been test cases and it has been successful as well. I don't know how much time it will take for the industry to adapt to the whole thing. But yes, semi-autonomous is here to stay. Definitely a lot of automation will take place on board. Some things will be automatically done and some things, I mean, few years back we never realized we can have a UMS ships, unmanned engine rooms. I mean, never heard of things. So could be unmanned bridges or for that matter, unmanned steerings where you don't actually require a person to stand on a steering. So all these trainings by creating digital replica of real ships ashore. That training will also happen over the years. It will take time, but it will happen, for sure. Case studies are already there, so I'm sure these all things will be a part of it. So, supervised and unsupervised learnings. So, now it is not dependent on an instructor to actually do everything. There will be unsupervised as well. Automated assessment is something which I talked about. There will be no fixed databases. There will be dynamic databases with dynamic questions, dynamic situations thrown at you. There will be no person making a question paper or something like that. Same goes for simulators as well. So there will be, scenarios will be created automatically. There will be no humans involved. Probably it will be real scenarios imported from the vessels. So this is something which is going on and will be coming into play. All these artificial intelligence cargo planners are already there. A lot of these pump operations and everything will also become automated, basis the pressure and everything. So those systems are also there. So let's adapt to the new technologies, and let's not say that it's always scary that it will take away jobs. I say it will create new jobs. It will create new skills. The way of learning will change, definitely. And let's welcome that with open hands. Thank you.
Thanks, Captain Bajaj, for your insight to the future. Now, Mrs. Georgopoulou, how can we get prepared for all these changes?
Thank you. I think that all the aspects that have been presented by the previous speakers can be collected in one thought, that the fuel to the future is collaboration. Collaboration between different partners, understanding the needs and the opportunities in each different field and among different stakeholders. So digital transformation can be considered to be a tool, practically a stream that could be used in order to transform, to speak to each other in a more efficient way, to manage data sources and data streams in a way that multiple operations and multiple activities can be held within an organization. So how can we get prepared for this kind of future? We need to start from the head. So on a management level, to transform and redesign organizations with principles and with strategies that align to digital transformation and utilize digital transformation as a tool for decarbonization. And that, of course, will need adaptation of the different operations within a company, people to talk to each other and collaborate on different levels. So avoiding the silos within organizations, so to say. And of course, moving towards the implementation of different solutions and plans. There we will meet all what Mr. Bajaj was saying about technology, challenges related to developing skills, to identify talents within organizations, to identify the right solutions that could be outsourced regarding, like, for example, connectivity, platforms, IT solutions. So we can be talking for many, many hours about AI and IoT and other stuff, but all these have, in the deep dive of the technology, differences. And these differences will need to be tackled according to the special needs of each its different shipping organization. Cybersecurity, data management will be part of this implementation, and all these plans need proper settings of KPIs, of planning at strategy level towards the end solutions and decisions. And finally, human resources. We talked about development of skills, we talked about talent review, but also it's important to consider outsourcing, expanding collaboration between organizations. All this, I believe, that could pave the path to data-driven ship management, to digital transformation of shipping. Let's not consider shipping as a silo, because it's a way, it's connected to a huge chain of different decisions that are being taken now in digital transformation themes. Thank you.
Thank you. As you see, we are running out of time, so we will not proceed with more questions. From me, at least, I want to thank all the panelists for their input and insightful answers, but we can leave a couple of questions from the audience.
I think the audience wants a coffee break. Dipon, first of all, thanks very much for moderating this panel. Thank you very much, everybody. It's very interesting. We learned so more than what we knew before. Now, ladies and gentlemen, can I suggest that the coffee break, we've actually put